Welcome to yet another class. I'm Dr. B, your chemistry teacher. Today we are going to be discussing chemical bonding. Today we will look at chemical bonding. Now, it's important for us to know that a lot of atoms do not exist in their free states. They are very uncomfortable in their free state, so they always prefer to bond. Either they are bonding with themselves, like the case of hydrogen molecule or helium molecule or lithium molecule. They either bond in that way or they bond with another atom. Now, what is chemical bonding? Chemical bonding is all about the attraction of the atom of another another type of atom with what, with the electrons of another type of an atom. So usually you see that particular attraction, that particular bonding coming forward. So chemical bonding as it is has to do with what? Has to do with the formation of molecules by what? By the combination of atoms. So hydrogen atom can combine with another hydrogen atom and gives you what? A hydrogen molecule. Now, the reason for this very kind of bonding is to allow for stability. Like I had said earlier, you do not have atoms that are free in nature being quite stable. So usually for them to obtain that stability or to obtain that particular nearness to the noble gas configuration, it is always important for them to do what? To bond. Now, let us make ourselves understand the fact that chemical bonding is divided into two. So you have the strong bonds. You have the strong bonds. You also have the weak bonds. And strong bonds are always being described as interatomic bonds, while the weak ones are always described as the intermolecular bonds. Now, for the strong bonds, we have the ionic bonds. We also have the covalent bonds. We also have the coordinate bonds. And we have the metallic bonds. These bonds are classified as strong bonds, usually featuring themselves around the atom. Now, in the weak bonds, we have hydrogen bond. We have hydrogen bond. We also have the van der Waals. We also have the van der Waals. The van der Waals forces of attraction or bonding, as you may want to describe them. So usually in chemical bonding we have strong bonds, weak bonds. Strong bonds are interatomic bonds, and then the weak bonds are intermolecular bonds. And usually the strong bonds are the ionic bonds, covalent bonds, coordinate bonds, dative bonds, and the metallic bonds. And then the hydrogen bonds and van der Waals force of attraction are described as the weak bonds. Now, I want us to know that with whichever bonding nature that we have here, or bonding type that we have here, bond formation is always exothermic reaction. That means that whenever bonds are formed, there is always heat given out to the environment, and this is because there is a reduction in the system internal energy whenever bonds are being formed. Now, our interest today is in the ionic bonding. So we are going to look at the ionic bonding. But before we look at the ionic bonding, agreeing to the fact that bond formation is always a consequence of a lower internal energy of a system, how is this bond being formed? How is this bond being formed? We're going to use a hypothetical energy diagram to describe that process, how bonds are formed. Now, Now we're going to use a diagram to explain that. Now I want us to take a look at this. Now let's see this and let's see this. Okay. Now you take a look at this. Look like a cyclic voltammetry plot, but this is where you have the potential energy increasing and decreasing. This is where you have your internuclear distance arrow. Now this is the total energy of the system, and this of course is this is the repulsion. This is the repulsion interaction. Repulsion interaction. And here we find fluorine, and then we have some points here. This, they explain the radius, okay, the internuclear distance. Let's say this is 67, let's say this is 97, and then now at this point, let me make this dotted line so it is going to be different from the rest. It gives you a clearer picture of what we're talking about. Okay, now at this point here, if we choose to do a tangent across, you'll see that at this point here is where we have the reaction of hydrogen fluoride, and at this point here we could also have hydrogen. Now, how do these atoms combine to form molecules? This is typical of hydrogen fluoride, for example. Now, if you take a look at this diagram, look at where fluorine is. Fluorine has a higher energy than hydrogen, which means that hydrogen will even have the propensity to do what? To combine or to bind with fluorine than even fluorine trying to bind with hydrogen. At this point where fluorine is, it is having a higher system internal energy. It becomes very difficult for what fluorine to do what? To bind and bond. So there is always a repulsive attraction for fluorine at this point because of the high energy. For hydrogen, at this point, has a lower energy than fluorine. But even at this point, repulsion is still noticed. Now, at this point where you have this tangent drawn here, it shows what? It shows rather an attractive interaction. See? So at this point where you have this particular tangent, you can see that it has a very low potential energy. So the system energy, internal energy is very, very low at this point. At this very lowest energy, hydrogen can easily bond with fluorine to form hydrogen fluoride. So it means that atoms combine with themselves to form what? Molecules. Only when there is, or when they experience, a very low system energy. Now that explains it. Now we go to talk about actually the ionic bonding. Ionic bonding is simply the bond that is formed between a cation and an anion. That means that if it's not a cation and an anion, where positive charges are there and negative charges are there, you cannot have ionic bonding. Now, we also need to understand that even at that, it is only the valence shell electrons that will undergo that kind of what? Ionic bonding. Only the valence shell electrons that will undergo ionic bonding. Let us take an example to explain our point. Now for ionic bonding, it is important for us to know that if we are bonding sodium plus chlorine to give us sodium chloride, we must know that there have to be an electron here. Now we have this. There have to be an electron here that is going to bond with this other electron to give us what? A stable compound. To give us a stable compound. Now we are going to further explain the ionic bonding in this formation. Now sodium configuration is 1s2, 2s2, 2p6 and 3s1, because sodium is what? 11. Now chlorine is what? Chlorine is 17. Therefore for chlorine we have 1s2, 2s2, 2p6, 3s2, 3p5. Do you know that if at this particular threes that we have here, okay, which are the principal quantum numbers that we have here, do you know that the S and P combination 2 plus 5 will give you 7? It makes chlorine very unstable. It makes chlorine far away from obtaining what? An octet state, or the noble gas configuration state. Therefore chlorine can acquire an electron from the cation to do what? To have 8 electrons at the valence shell, which gives it the opportunity of stability. Now we can explain this by writing this. Now this is the px, this is the py, this is the pz. We are directing the whole of this to this. Okay, now from here where we have the 5, filling in here, we have 1, 1, 1. We have 2, 2. There is something missing here. So now it will require this electron to do what? From the cation to do what? To balance this. At this point, we now have 2, 4, 6 plus this is 8. That means that the valence shell of what? Of chlorine has 8 electrons, and with 8 electrons, it has obtained an octet state. It is already having having the noble gas configuration. It is already a stable molecule. So it means that for ionic bonding, there will always be what? A transfer of electron from what? The positive, or let me say the cation to the anion, to allow for what? Stability and octet state. I'm sure that today we have been able to acquire new knowledge, or may have learned a new thing entirely from this discussion of ionic bonding. Next time we're going to deal with covalent bonding and the coordinate or dative bonding and metallic bonding, as the case may be. Do not forget to share, do not forget to like, do not forget also to follow, do not forget to subscribe at my YouTube channel. Until next time, it's bye for now.